All right, thank you for having us here again. It's good to be back at EnerGIS, and I know I'm between us and lunch, so I'll do my best not to go over and keep it short, sweet, and informative. Apologies, Nick from Energy Transfer was going to join us here. He can't make it here today. I've got some of his feedback, though, that I'll be sharing along the lines of this evolving weather and environmental threat. And as David mentioned, it's very relevant. You know, Hurricane Helen or Helene, or someone will correct me at some point, and I'll get that right, I'm sure, is bearing down here on the Gulf Coast. And let's see if I can't get this to work. All right. Boy, this presentation's falling apart already. Let's see. Buttons. All right, let's just go the old school way here with a mouse, maybe. Okay, is this working? There we go. Okay. So, I don't know about you. When I wake up in the morning, first thing I do is I pick up my phone. That is probably not a good habit. I don't recommend it, but a lot of us do it, if not all of us, right? And when I do, I might scroll some reels, but I'm looking at the news. And typically one of the first things that comes up is some type of major weather event. Just this week with a hurricane bearing down, this type of extreme weather event, while not new, seems to be ever more present and happening ever more often, right? You can see on the right there, this is a view within TerraView, our platform that we'll touch on here, but the takeaway here is you can see the weather forecast and the observed precipitation and radar-derived information there bearing down on the Gulf Coast, but the rain we're seeing here as well, it's a product of that, right? So, in addition, right, to the weather itself and some of the things that we're going to touch on here as where is this correlating with our assets, right? And so we're going to dive into that a bit more, but, really just setting the stage here that weather is ever present. It's not new, it's not something we're not aware of, but it continues to be a major issue for operators, owners of physical assets on this face of the earth, right? With that, some of the analytics we've performed here, right, to give a little more context, when we're talking about these types of environmental threats, these risks, right? In this region, very often that's landslides. Work with a number of operators, many of you represented here today, helping to identify, prioritize, and monitor these, right? But if you look even nationwide, lower 48, 925,000 square miles, right, of this area, land at high landslide risk. In addition, 807,000 square miles at high flood risk, and another 225,000 at subsidence risk, right? Karst topography, looking at sinkholes, things of that nature, right? So it's ever present. It's certainly an issue here, here in the Appalachian region, right? You can't throw a rock without hitting a landslide, basically at any right-of-way. So the effects of that, right, we've seen, and statistically here, some of the economic damage, one way to look at this, right, over, say, the last 50 years from these natural disasters. Well, unfortunately, that graph is going up, right, up and to the right. And over the last 20 years, I believe if you look at 5-year increments, we're seeing 10x for 5 years. So bad weather happens, it continues to happen, and it's happening more frequently. And with the more infrastructure we have to manage and operate, the more potential there is for that interaction, that intersection, and the bad things that can happen with bad weather. So we're aware of that. Probably you're supporting a lot of your companies from a geospatial perspective already looking at weather and these issues, right? A lot of key drivers as to why we do this. But a big driver is often regulation, particularly within this industry. Within the energy space and within pipelines in particular, PHMSA, they see this as well. And with a lot of the current regulations or recent regulations being pushed forward, a couple of snippets here from PHMSA that operators must monitor, evaluate, and respond to severe weather events. So keep that little snippet in mind. We're gonna circle back to that here in a minute as well. But not only that, operators should identify areas prone to earth movement and monitor changing weather patterns to evaluate soil stability, right? So the regulators, they see this as well. The 72-hour rule, weather and external force threats, call it what you will within the industry. It's something probably many of you are working on now, have been working on, and are very well aware of due to these key drivers, right, these regulatory drivers. So we're going to come back to a couple of those things here, but it's become a universal problem, right, within our industry. And the escalation of the number of events, the severity of the events, the safest areas already taken, right? And that really referencing, again, if you look out here, right, the good right-of-ways got taken real quick, right? So we've had to build on hill slopes in areas that maybe we wouldn't necessarily want to put our pipelines, but we've got to put them somewhere, right? We've got to get product from A to B. We have to do so. So how can we manage that given the variables that are playing into these types of threats? It's an issue, right? That increase in development, whether it's around our assets or if we're lucky enough to be able to put in new assets as well. And then as we peeked at there, that increase in regulation, right? That regulatory driver is always a key aspect pushing things forward, right? Or at least driving a lot of the work that we do for operators, a lot of the work you do supporting integrity teams and so on, all right? So I'm going to circle back real quick, again, to these PHMSA statements, right? And there's something that with the operators we work with, there's been a very common theme here. And that is, there's no real guidance what constitutes a weather event, right? There's some understanding out there, or there's some kind of baseline parameters that have been thrown around, like 2 inches in 24 hours, right? But as we've engaged with our customers and other folks in the industry, one of the number one responses we get when we say, hey, we want to talk to you about weather monitoring over your sensitive assets or over areas that are prone to landslide. Well, what is that threshold of precipitation that we need to be concerned with? So one of the quotes from someone we've been working with, 2 inches of rain in Arizona is a lot different than 2 inches of rain in Pennsylvania. So we can't apply just this standard threshold that all assets, all geographies are going to react the same, right, when 2 inches over 24 hours occurs. So that's been one of the key things that we've been working with our customers to try to solve. And on top of that, it's identifying that change that matters most. So we can start to understand how much precipitation we're concerned about, but where is that precipitation occurring? Is it just generally in the region? Hey, send the field inspectors out to go check every inch of right-of-way. I don't know about many of you here, but there's a resource constraint that's a real tough to manage aspect here for operations, maintenance, for any of the departments, right? So where is that change happening? What is the change that matters most? These are some of the key things. And then when that happens, right, back to that resource constraint, how are you prioritizing that next step, that field inspection to stay in compliance with the 72-hour rule, that next step to go out to that sensitive area, that right-of-way where there's a landslide that could activate to mitigate before it becomes an issue. So these are some of the things that we've been hearing from folks in industry that they're trying to solve as they try to stay in compliance with the 72-hour rule, as well as just safely maintain the operations that they have going, getting product from A to B, and all the other key financial and other drivers therein, right? So when we're talking about these environmental threats, right, and in particular, we'll stay pretty focused on landslides. That's a real common issue out here. So If you don't know Teren, we've been working in this region for years, and predominantly what we've done with operators is leverage LiDAR data, other remote sensing to identify, prioritize, and monitor landslides, right? This all makes it into GIS. Many of you here, the data may make it into your GIS that we've worked with, but beyond the identification, right, we may have identified, or you may have identified, or whichever means you've used to develop this inventory of landslides or threats, right, as they relate to your aspects. It may be sitting there, a landslide. Maybe it's not moving today, right? Maybe you've been monitoring it, but it's sitting there dormant, and what would trigger that landslide to move? What would trigger that to move? Most likely it will be weather. In particular, it will be precipitation, right? As water infiltrates the soil, geomechanics take over, the land starts to move. And so that trigger of severe weather is now adding this more real-time aspect of monitoring that particular threat. Now, the end result, in worst-case scenario, is some type of infrastructure failure, right? So that's an actual photo from, a operator not to be named, right, that had to go through that particular event where weather plus a landslide caused a particular infrastructure failure. Now, hopefully, you're getting to this ahead of time to be able to mitigate that, leveraging the tools at your hands, and in particular, the geospatial technology, right, that we all love and adore and use day to day to try to get ahead of this problem. Okay, so as we saw in the title of this presentation, right, we're looking at the evolution here, the evolution of the technology around weather and environmental threat management. Okay, so as I mentioned, traditionally we've worked with organizations to inventory those natural hazards, right? Create that in a geospatial format, get that into your GIS. You're able to identify those, monitor them over time, work with them, send data out to the field, be it through field maps or other means, right? Leveraging this great technology we've got. And historically, and even this morning, picking up my phone, I can see weather. You can see weather. Your control rooms have been using weather. You're probably using weather today. How many of you have already implemented some type of real-time weather into your GIS? Definitely a few, right? And I know we've got other folks here talking about their capabilities to provide weather as another tool, real-time data feeds. This is very powerful, right? So we can monitor that. And in its simplest form, I'm looking at the Weather Channel. There's a big storm coming. It's going to cross our assets. What are we going to do about it, right? Now, that real-time data integration of weather, right, the capabilities we have now within our GIS to bring in real-time data, very powerful. Many of you are already doing that today, right? You can start to integrate that real-time data, and now you're also probably able to intersect that with your assets, right? Again, power of GIS, this is core to everything that you do. So as we kind of move down that chain here, this evolution, we're hopefully many of you are already living there somewhere in that middle sphere, right, or in that middle part of the timeline. And we can start to integrate that forecast, observed weather data, that's coming through, integrating that with your systems. But where we really want to see this advance, and this is where we're working with folks and others as well, right, is taking that a step further. Not only integrating that real-time weather, not only the integration of the geospatial data that you have in your system, your asset infrastructure, your inventory of landslides if you've got them, whatever the case may be, but now can we start to apply data science, environmental science, to get to that root answer, if we go back several slides, what is the change I care about? Can we start to predict at what point that weather is going to make the land move? And can we use these tools to turn that around and feed that to our stakeholders, be it the field inspectors, operations integrity, whoever that might be, to start to get to those answers, to start to pinpoint where we really need to care. So, a couple examples here, to kind of pull that together, right? as we saw on that initial slide, we could see, that storm approaching, right? We can see the weather there. We can start to now pinpoint and intersect that with, be it a geohazard, be it a water crossing, be it a particular area of concern, whatever that might be. But now can we start to use that data to predict when and where that weather will activate a dormant threat? Again, you may have a geohazard library already with hundreds, or some cases thousands of these, many of them sitting dormant, right? What's going to change that? Where do we need to focus? And this type of technology, it's not the landslides you're already working on, right? You already know about them, whether they've already caused some type of bending strain or there's been movement, you're out there mitigating them. It's not the ones that are subsurface, way off right away, that, yeah, we've captured that, we don't really care about. It's those ones in the middle. Maybe it's not doing anything right now, but boy, it's upslope, it's translational, whatever the characteristics might be. If that thing starts to slip, that's going to cause a problem on our pipeline. So as we start to pinpoint the where and the what kind of change, now we can start to get that information out, right, to the key stakeholders to understand how do we prioritize those resources. So, as I mentioned, Energy Transfer was going to join us here today. They weren't able to make it, but I was able to get some feedback, and we've been working with them, right, on this enhanced environmental intelligence platform, TerraView, to be able to bring this data together. And one of the issues, right, so in this case, among different organizations, there's varying program maturity when it comes to, say, geotechnical or geohazards, right? Some companies have put a lot of dedication and dedicated resources for that, having internal geotechnical engineers. Some companies have not, they outsource, there's certainly that kind of spectrum, right? In their particular case, they'd already implemented some thresholds within their SOP, right? That was based on the best of their knowledge, right? Some industry standards, no, they're not just throwing a dart at a board and saying, let's pick, 2 inches over 24 hours. They use some pretty valid at that time information to define those. One of the key problems that they were facing is, how do I get this information in the right hands when an event occurs? So in this case, threshold was already established, and we're going to circle back to that here with this same example. But the ability to inform the right personnel was a key component. So again, when that event occurs, where it occurs, who's the appropriate person to inform for that? The particular field inspector or operations manager over that system. Many of you may manage, hundreds if not thousands of miles of right-of-way, or hundreds if not thousands of well pads, or whatever the case may be. How do we quickly alert the right person so that, again, we're in compliance, we get the people out to the right place at the right time, and we're doing everything we can to ensure we're keeping, in this case, product moving through the pipe. And so you see an example there of an alert email, right, that would be generated upon that threshold being hit. Precipitation is over that 2 inches, or in this case, 1.5 inches in 24 hours in a particular case, 6 inches in 30 days, whatever that might be, right? The appropriate person can be informed, but informed with valid information. They know how much precipitation, they know what that particular hazard, in this case a landslide, might, what particular asset or hazard they're going to go inspect, where that is, and many of you probably work within your organizations to find ways to take complex data, complex information, and translate that into a format, into language that works, right? So it may not be a station and measure value, maybe it is. Maybe it's location information that it's, at the corner of A and B down in the holler, because that's where the inspector knows to go. It may be GPS coordinates that they can put into their field mapping application. Whatever that might be, right? Getting the right data into the right hands in the right format for the right use case. Now, Something very interesting, though, has already started to evolve in this process working with the folks at Energy Transfer. As I mentioned, a very mature program from a geotechnical perspective. And unlike a lot of the other operators I'm working with, had already established some thresholds that they wanted to work with. Beyond starting to capture that real-time information, one of the things we've done with TerraView is we're cataloging all of this historical information around precipitation and weather. So now they have an ability to look back to say, well, at this particular location, and in this case, at this particular landslide, let's look back and see all of the precipitation events that have occurred. Has there been movement? Has it stayed dormant? If we can look back and say, this particular landslide, you know what? It hasn't moved. We see that there have been X number of storm events that were over that 1.5 inches, but it hasn't moved. We now have information to go help revise, review that SOP, and improve that performance, improve that program as a whole, right? So that's something really interesting that's come out of this particular use case. Is it's not just the real-time monitoring, it's the historical look back, if you will, to be able to continue to revise an SOP, revise those thresholds, right, that you may be concerned with. So that's been something that has been really useful and helpful so far. And early innings, right, a lot to be learned and a lot to come from that as well. So I promised I'd get us to lunch pretty quick. I think we're pretty close to on time with maybe a couple of questions. A couple of closing thoughts. I'm probably not going to read those. I'm just going to tell you my closing thoughts, right? I mentioned something before around program maturity, right? And this is something you're probably all very aware of already, supporting the folks that you support from a GIS perspective or otherwise, is aligning that technology, right, in a way that works for them. So little things, right? Whether you're using Teren, you're using an internal application, you're using other vendors, right? From a GIS perspective, and again, I'm a GIS guy by training and ended up in sales, so be it. But we can all geek out on the cool stuff. How do we translate that in a way that is understandable and usable by that end user? There's a lot of solutions out there, right? You want to do your homework, and it's the same as anything, right? Is it getting you the answers that you need? Know your geography, right? And so again, there's so many aspects that can go into this, where geographically these assets are, what that particular climate, some of those other variables, soil, so many other little things I'm not going to give away our secret sauce on, right? But know your geography and then be able to continue to refine and revise what you think you know. And especially if you've got the data to support it, the data to be able to go back and make those particular analyses, you can improve your program continually that way, beyond just the real-time monitoring, right? We all know we want to maximize geospatial data. There's so much information at our fingertips now, and there's so many incredible things that we all do, that you all do within your GIS programs. The data, the technology is out there. It's not necessarily always a one-stop shop or an easy button. It's a combination of your skill sets, the data, the technology available, and then making that work for your end users. But with that, I think we're hit the 12:10 mark. I think that's when I'm supposed to wrap things up. And that's it. Yeah, if you're interested, please do chat with me some more. I know this was pretty high level. My colleague Sam in the back as well, happy to answer questions. And there's a QR code on some of the Industry Innovator Program stuff we're doing around this real-time weather monitoring. But with that, I thank you.
Time for questions if you have any. When you're talking about threat predictive systems, I know weather does play a large role in initiating these landslides or reactivating them, like you thought. But there's a lot of other multifaceted problems that sometimes you don't have all the data for. How do you guys deal with that in building some of your predictive?
Yeah, no, it's a great question. There's certainly a lot more. So, we deal with a couple of different solutions and use cases. In some cases, we're going out using LiDAR to find that actual issue. But in some cases, we're using data to find areas that are prone to a particular issue. Weather, climate, soils, there's a number of other variables that go into that. A lot of that, we can kind of farm a lot of that information from commercial data sets. Some of that has to be curated in a particular way. You look at, soils data, variability from state to state or county to county. So a lot of the kind of grunt work behind the scenes to even just prep that data. But then we get into just a lot of the cool data science and environmental science to start to put those variables together. Nothing that we do, or to my knowledge anyone does, is perfect, right? Prediction is a tough thing, but done a lot of statistical validation on some of our predictive analytics with really high correlation. And one of the great things is because we have high performance computing, machine learning, AI, some of these technologies, we can start to do a lot more leveraging the data we've got that's out there. USGS landslide database, right? I mean, we've got a huge database of landslides from the work we do, but the USGS has a huge historical one. How can we start to use that to not only train, but then to validate some of these predictive measures? So a lot of other data sets that go into that, but beyond weather. We just know that that's a real-time feed that we can use now that, to a question earlier about the heavy-handedness of LiDAR and the expense of LiDAR, there's some things we can use now that don't necessarily require that you go fly twice a year. It's still important, and we do so for many operators, but a lot of other data sources we can use to at least hone down where we should be looking. I'm between us and lunch. I know it.
Well, actually, lunch just got delivered, so we have like an extra 5 minutes. So if you haven't, I know Tim is going to do a long song and dance for us. So if you have another question for Jake, feel free to ask him, and then we'll bring Tim up.
Do people try to prevent landslides? I mean, if you know where they're prone to happen, do they try to go around the landslides? Or, I mean, if it's going to happen.
Yeah. I mean, and some of that depends, right? So sometimes this technology is used in a routing perspective, right? So this technology could be used to at least say, don't put the pipeline right here. There's terrible hydrology, bad drainage. There's signatures that a landslide could occur.
Or if it's already built, do people reroute it?
Yeah. I think more often what we see is, so one thing I didn't really touch on here, one of the key analytics that's driving a lot of this is a hydrology analytic, looking at surface flow hydrology. So you can use that type of technology along a right-of-way to perhaps see where a water bar is failing. And if it's not dewatering properly, that could be feeding, that could be one of the triggering events. So there's proactive things that can be done that are done, fixing a water bar. There's other civil engineering applications, that this data can help inform to say, if we do this here, it would hopefully prevent a landslide. Very often what we're seeing is a landslide's identified, but it hasn't yet affected the pipeline. So what type of mitigative efforts, retaining walls, soil nails, so on. I'm not a geotechnical engineer, but a lot of the work that could be done there. So if you can find the potential problem, there's typically some mitigative measures that are going to be a lot less expensive than if it slips, if you've got to go dig up the pipe, and God forbid you've got a shut-in or an incident or something like that.
Do they shut off their pipelines in heavy rain events?
Again, I'm not a pipeline operator myself, right? But I think, we try to help ensure that they don't have to have a shut-in. Now, the shut-ins happen, right? But if you can get ahead of it, and again, full disclosure, I'm a sales guy, right? I'm trying to sell, but it's like selling insurance, It's not a top-line revenue generator, but for companies that are looking for ways to try to mitigate those risks, it can help avoid a shut-in. I mean, we've done other case studies for that type of work that we've done as well that has shown elimination of shut-ins in high landslide-prone areas if they're able to mitigate.
mentioned real-time data in terms of weather and that sort of thing. Are you seeing any incorporation of real-time or near real-time data from the other end of things? For example, whether it's seismic sensors, fiber optic sensing, things of that nature to give you an idea of what's happening underground or on the ground?
Great question, and certainly a pretty common topic of discussion. For us ourselves at Teren, so far, we've been pretty hyper-focused on leveraging some of these key real-time data sources, such as precipitation. But it comes up very often, and technology, Teren or otherwise, right, is built in a way now that with IoT and sensor technologies and the APIs being available, that you could start to bring that in, right? And again, some of you may already be doing that internal to your GIS with what's out there, but certainly something that comes up a lot: seismic, lightning, hail, a number of other weather events, right? Right now we're focused in on the precip, but those are certainly on the horizon.
How frequently do you resurvey these sites? So if you have a big weather event, you go back out there and scan it again, see how it affected it, or what?
Great question. Yeah, typically, historically and still today, right, LiDAR plays a key role. And that's typically fixed-wing manned aircraft, right, for the type of LiDAR we're using. You got to do it with leaf off, fall and spring, right? It's expensive, and it's pretty restrictive to those times. This is where something like real-time weather monitoring, where it doesn't require any type of manned airplane or data acquisition. We're using existing data sets, so whether that be existing LiDAR-derived analyses, whether that be existing data sets that you've generated from field inspection or other vendors, INSAR, you name it, right? That baseline data in conjunction with real-time weather, now you've got something that you're consistently trying to use to prioritize those particular areas, monitor those particular areas, so it doesn't require that type of regular inspection. But in this region, a lot of folks still, twice a year, are getting that refresh of LiDAR. A lot of change detection you can pull out of that. Again, highly resolute digital surface models and things like that.
Last question.
On that note, do you have any customers using drones with LiDAR to okay, we've identified, now that we've used that, large LiDAR to kind of pinpoint these dormant or high priority areas, is anybody using LiDAR drones to just monitor those sites and bring that data into your application?
That's a really good question, Christine. And I would say generally yes. Drones continue to we see more and more both internal drone programs or leveraging local vendors for those types of things. Certainly pros and cons, as you're well aware, on one versus another. But at the end of the day, we're looking to see how can we consume wherever that data is coming from, right? If we can get a good DTM, DSM, a good derivative from whatever point cloud or sensor is available, the more data, typically the better, right, to be able to get those questions answered.
Thanks, Jake.
All right. Thank you.